Hello, welcome to Chapter 2. This chapter has a lot of the descriptive type statistics, meaning graphs, and how to make them, how to analyze them, and how to use the data effectively. Graphs are used in presentations in businesses all the time, and so having some sort of knowledge of how to create these graphs in a way that really does show what the data means is very important. So we're going to start off, there's the list of the objectives. You can find those in your book and in the syllabus as well. But just to remind yourselves, what we're going to be doing is displaying this data and recognizing and calculating things about this data. Where is the center of the data? Is it spread out or is it really compact? Those kind of measurements we're going to talk about. Some things you'll be familiar with, like mean, median, and mode, and recognizing how to talk about the variance, the difference, the highest and lowest, the range, things like that. So that's what this chapter is about. In the reading, you will find a lot of things, and hopefully through this series of little videos, you'll kind of be able to weed out the things that are important for you to know and things that are just nice to know. So stem and leaf graphs are first up, and you can read the information here. Really, it's how to bring a lot of data together in a very visual way. There's a whole separate video on stem and leaf plots in the graphing video section in this materials and resources. There's a whole folder that has all the different types of graphs and how to do them. So I won't spend a lot of time here, but this example gives us some data, and you may remember this from some of your previous workings in either stats or probability in some of your other classes. But it creates a chart like this where we have a stem, which is the first number, and then the leaf. Now looking just at that first number, this right here, I'm just going to underline right through here, represents the number 33. So that is how it is written, our stem and our leaf. So I'm going to kill my little pen so that I can continue talking. So that's what a stem and leaf plot's about. If you have more questions, the book has information, as does a video in the other folder. A line graph is used a lot, right? It takes the data that you find in this table and it turns it into this type of line graph. Line graphs are used a lot in business, and so understanding how they work is important. Notice the two axes. Our frequency is going to go on this way, and the number of times that that they needed to be reminded is this way. So how many teenagers needed to be reminded 0 times? Well, there were 2. That is how we read this graph. So you have 2 different axes, we call them, as we go through the line graph. So again, there's another video on that if you need more explanation. Here we have our bar graphs. Again, we take this information and notice that these are in ranges here. I'm going to just kind of put little lines under those. And they're grouped data, right? And so the book tells us the appropriate way and some of the equations and formulas to find what the best grouping is. This particular data, it is given to us in a group. But sometimes we're just given data and we need to come up with our own grouping. And there are a couple of keys. There's no real right way and wrong way, and that's different in statistics and other branches of mathematics. But there is certainly some, let's say, best practices that people use. And so the mathematics behind how to create those groupings is important. So that's in your book and also in that additional video. We also mentioned our histograms, frequency polygons, and time series graphs. I do not have any problems on the time series graphs, so read those as you would like for your own information, but I don't believe there's any problems for homework that are talking about the time series graphs. Histograms are pretty important. They look like bar graphs, but they touch each other, right? The edges touch. That's why they're contiguous. The contiguous adjoining boxes. And it has both the axes, just like the bar graph does. But the horizontal axis is always labeled with the data that it's talking about. The vertical axis is going to be the frequency or relative frequency. So constructing the histogram, there are some instructions, and there is another video about that, but there are instructions in your book as well. Frequency polygon has information that could also be shown in a histogram, something like that. You notice that we have here an interval, just like we would in our histogram, where it starts maybe at, from 10 to 20, something like that. Here we have the same type of thing represented in our frequency polygon. So how many times did this event happen in between these times? And we go from 0 to 5. So here we have columns. Now, in statistics, it's kind of important as we write our data down that we keep it organized. So we have our upper and lower bounds here, lower, upper, how many times that happened. And the cumulative frequency is just going to be adding. So the first line is just as you see it. We start here at 44.5, we go up to 54.5. And how many times do we have inside that interval? It was 5. Since it's our first frequency, our cumulative frequency is just 5. When we look at the next interval, this one going right here, it's mentioned by a lower and an upper bound. And in that interval, it gives us 10, right? 10 things happened there. We got up to the 10. The cumulative frequency, though, we're going to be adding those together, that 5 plus that 10. And that's how we get our next cumulative frequency. We add the amount, and we add it to this, and that gives us this down here. So that's explained as well in that other video in a little bit more depth. Here's drawing up those frequency polygons. Sometimes you can compare information, from one year to the other year, first test, final grade, those kind of things. It's a good representation to do that. Time series graph, we're not going to get into, but it really is quite common to want to track how things go over time. And so we were talking about, here we are talking about an annual event and how, my marker's not there, an annual event. And so we want to track it over this whole group of years, right? So over here we can see what our index is for whatever we graph. You see these kind of graphs quite often. I'm not going to spend a lot of time, like I say, in the explaining because I am not requiring any problems about these. So that's kind of an overview of the different types of descriptive statistics. Hopefully between this little video and some of the things in the graphing folder, you'll be able to answer your questions. That and the book, of course. Thanks.